Well, hello everyone. Welcome to the Reactor Summer Series,
Hello,
where we're going to be
everyone.
talking. Yeah, I will admit I do feel a little bit awkward announcing that we're doing a session in a summer series because Justin, my co-host, and myself are both in the southern hemisphere. So
Yes.
it's not really summer, is it?
Yeah, it's
Uh,
currently 13 degrees Celsius here in Melbourne. So I'm not sure
yeah,
if we can call it as a summer.
Yes, but I mean, it's going to be somewhere, and chances are some of our viewers on today are enjoying summer. But at least for me, calling it summer is making it feel a little bit warmer because it has been a bit chilly the last few days. That's for sure. Uh, but anyway, let's kick off today's session. We're going to be talking about building reliable web applications with Azure and .NET. But just to get started, allow us to introduce ourselves so that you know who we are and who you're going to be spending the next couple of weeks with. My name is Aaron Powell. I'm a principal cloud advocate in the .NET on Azure advocacy team here at Microsoft. I've been doing web development for close to 20 years, and probably as vague as I'll be ever on a stream because I don't want to like fully age myself. But in that time, I've been doing web development my whole career, and I've seen every kind of a style and approach to building web applications that we've had. Before joining Microsoft, I was doing consulting work, so I got to work with a lot of organizations and see a lot of different approaches to doing enterprise application delivery. You'll find my social media and contact details there on the screen. So if you have any questions after the session and you want to reach out, feel free to ping me on a variety of social medias or drop me an email. But we will be doing Q&A as well. So drop things in the chat if you've got questions for us as we go on, and we'll get to them either on the fly or at the end of the session today. But anyway, Justin, over to yourself.
Yes. Hello, everyone. I'm Justin. I'm as a senior cloud advocate at Microsoft. I have the similar background, web development, but I'm mostly on the backend development. And now I am mostly interested in the platform engineering and integration engineering. So yeah, so using the Azure and .NET as well. So these are my social media profile and email address and my blog, the website. So if you want to reach out to me, yeah, just shoot me the message through either on the social media or email. Okay, so I will hand over to Aaron to get started.
Thanks, Justin. So what are we going to be covering over the course of the next 5 weeks? And I guess to really set the scene, I want to put you in the position of the developer or the organization that we're going to be going on this journey with. And maybe it's what you're working with day to day at the moment. It's a fairly common scenario that we've seen, and that's you've got what we might term as a legacy web application. It's probably designed as an N-tier architecture. So we've got like a web front end. We might have an additional API server that's providing some JSON endpoints, so we can do a bit more of a dynamic user experience. But it's still predominantly just like an ASP.NET web server. This is then talking to a SQL database. You might be writing some files to disk or some other kinds of storage. You might have some other auxiliary systems that sit around that. But again, this is really just a fairly standard sort of ASP.NET application. And that's the context of what we're going to be building today. And throughout the next couple of weeks, we're going to be looking at taking that to be more of a cloud native or cloud ready application. And we're breaking this down as a number of different components. The primary thing that we're going to be focusing over the next 5 weeks is converging on the cloud. So this is going to be the journey that we're taking with our enterprise web application. It's kind of the first step along that pathway to being a cloud native application. And in converging on Azure, we're going to be leveraging more of the features that the cloud offers us. We're not going to be necessarily just lifting and shifting those virtual machines so that we've run from an on-premise data center to a cloud data center and we've just replicated exactly the same thing. And we want to take some advantages of what cloud gives us and why that makes for a good value proposition in what we're building. The next stage of the journey would be to go into a modernized phase of your application before finally looking at the scalability phases. Now, these are all separate phases that we can tackle. And like I said, for the context of these 5 weeks, we're really only going to focus on converge. And it also means that all the stuff we're talking about here, you can stop at any point in the time. we can complete our journey at converging on the cloud, and we have our production-ready application. It's still going to be running. We're still going to have met a number of goals we've got. We don't have to go down the other paths if we don't want to, or if as an organization, we're not ready. So that's the theme of what our Reliable Web App series is going to be. Let's have a bit more of a look at what we mean on that converge topic. So when we're talking about reliable web app patterns, we're really talking about this in the concept of, well, I guess, patterns like you might think of them in any kind of software project. We work with, we build patterns, whether they're singletons, factory patterns, actor patterns, messaging patterns, whatever the case may be. But fundamentally, these have a series of inputs and they produce outputs. We might have tooling that supports them. And it's the same when we're building a reliable web application. We have a series of inputs to this, things like the cost profiles that we're targeting. We want observability and service level agreements that we have for our customers. We want to tackle things like continuous integration and continuous delivery, so we can deploy from our dev environments to production in repeatable, consistent manners, and also so we can do rollbacks if we do have things that go wrong. We're going to look at some new tooling, such as the Azure Developer CLI. And of course, we're going to be building this with .NET. Justin and myself are both .NET developers at heart, so that's where we really want to focus. Underpinning all of this is going to be the Azure well-architected framework and 12-factor methodology. We're going to touch on a bit of those more as we dive in over the next couple of weeks. But the end goal is that we should have an application that is in the cloud and is able to hit a bunch of new components that we previously didn't have. We might have more reliable service communication between the components that make up our application. We may be looking at multi-region, so we are not so constrained on a single set of resources in a single location, and we can distribute our traffic more effectively. We might be looking at things like immutable infrastructure, and that's really going to be one of the key tenets that we'll have over the next couple of weeks, is how we build immutable infrastructure. Because fundamentally, this kind of a project, building reliable web applications, is not just a software project. It's also an infrastructure project. So we want to make sure that what we're doing is also taking the infrastructure considerations into mind. Like I said, we're trying to address the challenges that you've got with an ASP.NET application. This might be an ASP.NET application that's written for .NET Framework, and we're looking at how we can migrate that to the new version of .NET or .NET Core. I kind of feel like, is it .NET or is it .NET Core? Because .NET Core was kind of like up to like 3, and then we've got .NET 5 and 6, which are just .NET, and 7. So let's call it .NET. We're going to be moving from .NET Framework to .NET. And in doing so, we hope to have a more reliable, scalable, and modern web application. Maybe we can tackle things that are more cross-platform that we haven't previously been able to do. But underpinning all of this is going to be, we want to tackle things like cost efficiency, because, well, if we're making things a lot more expensive to run our application, that's a hard sell to our business, right? Management is going to look at it and go, well, you said that going to the cloud was going to be beneficial, but why are we paying an exorbitant amount more? Well, Justin's going to join me back later on today, and we're going to talk more deeply about cost optimization and how you can do that with inside of a reliable web app pattern. So the key objectives that we've got for this is, well, we want to focus on things that are going to be low cost but high value wins for the business. Like I said, you don't want to be doing things that are going to be resulting in more expense for an organization, because that's going to be a different value proposition. But at the same time, you don't want to do things that are going to be highly risky or are going to take a long time to tackle first up, because that's going to have, again, difficulty representing the value you've got for the people that are investing in this new work stream. We're going to be tackling the principles of the Azure well-architected framework. Now, over the course of today and then the next few weeks, we're going to be digging more into the well-architected framework. But if you want to jump ahead and have a read about some of that stuff, you can check it out at aka.ms/EAP for Enterprise Application Patterns /RWA Reliable Web Apps /WAF well-architected framework. And that's, well, I mean, it's a technical talk. You've got to have TLAs, or 3-letter acronyms, as much as you can throw them in. But trust me, that's a lot shorter a URL to memorize and copy down than the full link to our docs resources. And like I said, there's a lot more resources on that page that we're going to kind of cover off over the next couple of weeks, but you can dive into those in detail there too. Fundamentally, we want to be doing this in a way that's going to result in the minimal amount of changes to the code that we have inside of our application. because we are going to be migrating to the cloud, which means that we are going to be introducing change, predominantly change at an infrastructure level. But we don't want to also introduce code changes to achieve that. We might have some code changes that we have to tackle, and we'll talk about those when we look at the architecture that we're going to be targeting for this. But if we're doing really large code changes and infrastructure changes and methodology changes all at the same time, we're introducing a lot of places where things could break, and we could result in a less efficient, less performant, or less reliable application for our organization. So fundamentally, we want to keep things with as minimal amount of change as possible. And we want to tackle things such as multi-region deployments so that we can have availability of our application is going to meet the SLAs or the service level agreements that our customers are expecting, and optimize the cost for both production and non-production workloads. Because leveraging the cloud does mean that and building more reliable web apps means that we're going to be leveraging features of the cloud that are a lot more difficult to replicate for a local development environment. Platform as a service, for example. Well, we don't really do platform as a service on our development machines. We want to get those into the cloud. So we want to get our application into the cloud as soon as possible so that we can then test it. But we also don't want to do that in a way that we're just going to see, again, an n-fold increase on our infrastructure spends. So the reliable web app pattern is made up of the 5 core pillars of the Azure well-architected framework. And let's have a look at those patterns. The first is reliability. And I think this is probably, at least for me, this is the most important one. I mean, it's also there in the name of reliable web apps. So I think we can probably agree that it is a pretty critical one. We want to make sure the applications, as we move to the cloud and build more reliable web apps, that they are still meeting the expectations of our customers. Customers might be our external users coming to a website, or it could be internal customers. And because we've got a line of business application that we're working with. We want to look at security. We want to make sure that we're still tackling the same sort of security mindset that we have when we're building for on-prem or for traditional infrastructure designs. And when we go to the cloud, we're going to make sure that we're not opening more attack vectors because we have potentially more surface area for our applications. Again, we'll see that in the architecture that we're working with in a little bit. I've talked a bit about cost optimization already. And Justin's going to dive into cost optimization and what we can do from a deployment approach and from an infrastructure design to tackle costs for different environment styles without having to have radically different environments for non-production versus production workloads. Operational excellency is all about making sure that our application is continually running and staying available to our customers, even as we're doing multiple deployments. We want to have automated deployments so that we're not relying on push from my machine to end up in production because, well, just because it works on my machine doesn't mean it's going to work in production. But also handle things like rollback. What happens if we do push a bad build out to a test environment or maybe even a production environment? How do we get back to a state that we know is working and resolve those bugs with as minimal friction as possible? And lastly is performance. What can we do by leveraging the cloud that's going to make our application more performant? Because ultimately, that's what we want. We want better value for our customers, and we can do that by having more performance. Well, that's really going to be that's going to give that good value to our customers. Like I said, this is all designed from or brought out of the Azure well-architected framework, and these 5 pillars are the pillars of that Azure well-architected framework, and that leads into doing 12-factor application design. So as I said, if you want to know about this kind of outside the scope of just this particular reliable web app pattern that we're looking at, I really recommend checking out the Azure well-architected framework. Okay, so what are we going to be building? Or is this going to be 5 weeks of death by PowerPoint where it's just going to be slide deck after slide deck? Well, of course, we wanted to make sure that you can learn by doing. And for that, we have a reference implementation of a reliable web app. This is a .NET application because, well, Justin and myself are both .NET developers, and we wanted to demonstrate how you can do this with a .NET application. This is a production-ready application. I'll jump over to the browser and we'll have a play with it in a moment. But you can grab it off GitHub repo, and then you'll be able to just deploy that straight out to production. You'll be able to have a look at the reference architecture we've got in there, and you'll be able to, you can play with it, change things, and see how that changes the way this is deployed and running with inside of the cloud. Because fundamentally, we want to make sure that we can show our best practices and we can give the guidance that we would expect someone to receive beyond just watching a series of videos, joining some live streams and things like that. Me personally, I'm very much a learn by doing kind of person. So the fact that I can actually grab the code, I can jump into it, I can deploy it, I can see the resources within inside of Azure, I can change things and see that impact gives me a lot more confidence in what is being done and that I actually understand what's being done. I can read all the documentation in the world, but until I actually see it in action, well, it doesn't always gel for me. So what's our application? Well, the application we've got is for a fictional company called Relecloud, and they manage concert tickets. So this is it's actually going to be a line of business application. So it's for internal employees of Relecloud. Think maybe like a call center. You've called up and you're purchasing tickets through the Relecloud system. Now, I want to stress that this is a production-ready application. You can deploy this into Azure and run it and have the architecture working the way that we would expect it. So let's jump over and have a look at the Relecloud application. Here it is. We've got it running in the browser. You can see that I'm logged in using Azure Active Directory into my account. And I can jump around. I can have a look at what events are upcoming. I can go through a process of let's purchase a ticket for, say, this event. So let's add this one to cart. We'll grab a couple of tickets. Click confirm. Go through the checkout process, and let's put in some details. And we'll pop in my details. You'd be amazed how infrequently I spell Microsoft correctly. Like I've been working here for nearly 5 years and I could still get that wrong so often. It's also worse when you're on stream and you're trying to talk and type at the same time. It's also using a mock credit card provider, so don't feel like you're actually giving us your credit card details or anything like that. We're not capturing that for you. Okay, excellent. There we go. We've purchased some tickets. It's generated a barcode for this ticket. That barcode or that image is stored in an Azure storage account because, well, this is running in Azure. I don't have physical disks that I can read and write to, so maybe this is the kind of change you have to make to your application instead of writing to like a disk. A physical disk, we're writing to a storage account so that we have storage that is persistent between deployments across machines, and as we scale out, it's not just fixed to like one instance of our web server. But that's So this is the basics of the Relecloud content application. We can come back and we can see all the tickets. We can navigate around. We can purchase more and things like that. So, how do you grab this, and if you want to have a play around with it, you'll find that up on our GitHub at aka.ms/eap/rwa/.net. And that's got a whole bunch of the instructions, kind of what we're going to be going over today. It talks a bit more about the methodology. So again, like if you want to get a preview of the content that's coming over the next couple of weeks, you can have a look at it there. But of course, you can jump in there and play around with the code as well, and get a feel for the kinds of applications that and the kind of implementation of this reliable web app pattern. But that infrastructure that I have in the cloud, well, what did it look like and how do we actually get there? Well, let's start off by actually talking about the infrastructure. And, well, here is an infrastructure diagram.
Oh, wow.
I've seen Justin's popped back in.
Oh, yeah. So that looks very overwhelming and that looks very complicated. So would you be able to explain more about the architecture in general?
Yeah, and look, I very much empathize with the people that are probably joining us on stream as well that are looking at this going, well, I thought you said this was a simple application. Like it's a web server, right? It's an NT web application. Why? We've got so much infrastructure here. It could feel very daunting about going to the cloud. So let's kind of break down what we've got. First off, what we've got here is 2 region deployment in Azure. So we've got region 1 and region 2. That's the left and right hand side of the screen. And the reason we're doing this is for reliability and resilience. Now, I know that you're going to be talking a bit more about how we made the decision to achieve this, Justin, in your section shortly. So let's just focus on what lives within inside of one of those boxes. This application consists of a web front end. It's an ASP.NET MVC application. And it's also got an ASP.NET Web API application that's providing a bit of functionality for the front end. As I said, some JSON endpoints. So we have two Azure App Services running there, or Azure Web Apps that are running for that, for those bits of infrastructure. This is platform as a service. So we have those, they're sitting there, and they're made available through Azure Front Door. And the reason we've got that is so that we can load balance across the two regions. Now, we've still brought in things like the Web Application Firewall, or WAF, in there, so that we have that level of security you would expect in a traditional infrastructure design. We want a firewall in front of our applications so that we're ensuring that only the appropriate ports are exposed, and we're reducing our surface area, of our vulnerable surface area, by having firewalling in place. We've also brought in things like the like Azure Key Vault and app config service to provide credentials into the various web applications that we've got. Now, this means that we're no longer needing to have a configuration JSON file on disk, or kind of the web config that we might have had in an ASP.NET framework application. And by pushing all those credentials across to Key Vaults, well, now we don't even have direct access to those inside of our app service from a file system perspective. So we're reducing surface area of attack as well. We're less likely to commit into our Git repo the credentials that we've got for connecting to our database, as an example, if we're not even going to be reading from that file in production anyway. And then we've got like our Azure Storage account, so that we can push that image across, the barcode that was generated, that gets pushed across there. And then at the very bottom of that diagram, we've got things like our virtual networking, because things like our SQL Server and our Redis cache, well, they don't need to be publicly accessible. I mean, when we think about this from a traditional infrastructure design, that's where we'd have like a DMZ. And we would put things that don't need external internet access inside of that. Well, we replicate the same sort of thing with virtual networking in Azure. We push away the stuff that we don't need public access to. And we have then an internal virtual network within Azure that just allows the resources that do need access to those back and forth, so that, again, we're reducing our surface area of potential vulnerabilities. So hopefully that does make you feel a bit more confident about understanding the things we've got in here, where we're trying to replicate the kinds of infrastructure design you would have in virtual machines in an on-premise data center, by leveraging the features of the cloud: virtual networking, Windows web firewalls, config management, and stuff like that. We're just leveraging, obviously, more cloud features rather than the features that we have in our traditional data centers. Okay, so let's have a look at how we can actually get our application up into the cloud. And we're going to go over to the GitHub repo, and let's start from scratch. I know I've already got it deployed, but let's start from scratch and grab a copy ourselves. So this is the GitHub repo. I said it's available at the aka.ms/eap/rwa/.net, or it's github.com/azure/reliablewebapppatterns.net, webapppattern.net. And let's clone this onto my machine. Here we go. I'm actually going to clone this on WSL, just kind of show that this is a cross-platform version. There's a button font size up a touch, and we'll go git clone. There we go. We'll pull this application down, and we'll come into the reliable web app, and let's open that up. And of course, I have a update that needs to be run for VS Code. I think every time we did dry runs for this, there was always a new update that I was installing. It's like, it wouldn't be a live demo if I don't have updates that need to be run. Okay, so here it is in VS Code. And there's a little pop-up that's just come here into the bottom corner that asks if I want to open in a dev container. I'm going to click yes, but let me just talk a bit about what the dev container is. And this is kind of an aside to reliable web app patterns, but I think it's something that is kind of useful, and I think could be of value to people that want to play with this. So a dev container is a way of setting up a containerized local development environment using Docker as the container hosting platform. What it's doing is it's pulling down a Docker image which represents the base set of dependencies that we have for the project that we're going to be working on. Now, this is a .NET project, so it's going to be bringing in the .NET SDK, and because the dev container is defined with the correct version of the .NET SDK, it's going to bring that in for us as well. At least it would if it didn't look like it's fallen over and crashed. So I'm just going to kick off a restart. Let's just like, of course, live demos. You can tell this is a live demo because things are going wrong. And look at that, errors after errors. Let's give it one more try. Otherwise, we might have to fall back to the one that I already have working.
Instead of using the
Yeah.
dev container, can we also use GitHub code space then?
Actually, yes, we can. So let me give it one more try locally. And if that doesn't work, I'm going to open this up in a GitHub code space. So let's cross our fingers and we'll see what happens. And if that doesn't work, we'll go to a code space. But yes, that's a good point. The dev container, because we're defining all the dependencies that are going to be needed, like what .NET framework do we need, or sorry, what .NET SDK do we need, not .NET framework, .NET SDK. So that will be installed so we know that we're not going to accidentally compile against the new version that we haven't tested with. We're going to install some extensions that we recommend for this particular project, or that are going to be useful for the project that we're working on, such as the Azure Developer CLI extensions. We're going to install other tooling that we need. So this is going to actually install the Azure CLI and the Azure Developer CLI so that we can work with that from a command line base, and we can deploy our application. All right. It looks like it has actually worked successfully this time. It's just setting up, there we go. It's just setting up some permissions and things like that. We'll leave that to go. But while that's running and while that's provisioning everything for me, let's just have a bit of a look into here. We'll see here that we have our Relecloud models, web, and web API. So these are the three .NET projects that we've got. So it's our web application. So we've got some controllers. We have our API application, which has some API controllers in it. We have things like services that we can talk with from our model. We have the data constructs because we're using Entity Framework. So we have like our database types that are in there. We have inside of, so we have like service implementations inside of the various locations. So we've got like our access to our database. We've got a database context as well inside of here. So this is working with obviously Entity Framework. It's also going to scaffold out some sample data for you. So if you do want to have a play around with this, we'll spin up some data as well. This is obviously all mock concerts and things like that. But yeah, so it's, like I said, this is a fully production ready application that you can get up and run. Okay, and it looks like we are up and running. So let's go ahead and actually deploy this to Azure. The first thing I'm going to do is I'm going to define an environment variable that will contain the resource group that we're going to play with. So let's just go rg equals, let's call it Reactor Relecloud. Yeah, we'll call it Reactor Relecloud. And then we're going to create, and using the Azure Developer CLI or AZD, we're going to create a new environment, and we'll give that the resource group name. Okay, and what that's done is it's defined a .azure folder in here, and it's started to set up some information about this environment that we're going to be working with. Next thing I need to do is I'm going to also add another environment variable. We're going to set the is_prod flag to false. Spell false correctly, because I'm going to deploy a non-production version of the application here. All right, and then all I need to do is do azd provision. And this is going to then go ahead and provision all the infrastructure within inside of Azure. The first thing it's doing is it's going to be grabbing, forgot, I haven't logged into my Azure account. So let's just do an Azure login. So let's do azd login. And let's go through and sign into my account. Okay, cool. So it says that we are logged in. Give that a moment for the callback to work. We had a few problems with this the other day when testing, but if that doesn't work, we'll use the different approach. No, there we go. Cool. We have logged in. Now we can do azd provision. So this is, as I said, this was looking at the bicep files, which is our infrastructure as a code files that we have inside of this repo, and it's going to work out what to deploy. I need to specify where I want to deploy it to. So I'm going to deploy to my Azure subscription, and then what region I'm going to deploy to. I'm just going to use East US because I've deployed to that one before and I know that it works. But this can be deployed to pretty much any region that you want. Now, this is going to go ahead and create a deployment plan, looking at the bicep files, which you'll find in this infrastructure folder. It's going to come into this main, go through and then have a look at what we need to deploy. Follow all the links to things like our resources.bicep. Look at that. We're going to deploy things like key vaults and so on and so forth. But this is going to take around about 20 minutes to deploy. We've got a lot of resources that we need to spin up. So what I'm going to do is I'm going to hand back over to Justin, and he's going to talk about cost optimization. Justin, over to you.
Sure. Thanks, Aaron, for the explaining the entire architecture and everything. So now is my turn for the talking about the cost optimization stuff. So as Aaron mentioned, the provisioning and deployment might take about 20 minutes or so. So in the meantime, so I will take care of the cost optimization stuff. And this cost optimization is very important because you might have been experiencing some sort of the billing shock. That's what I had before. So when we run applications on the cloud, we just don't provision and deploy the applications to the production, but also do the same thing on the development and testing. That means we should spend twice or 3 times more than we actually need. But let's think about this. Do we need the same resource instances for the development and testing? I mean, do we need to use the same pricing tier or something like that? The architecture would be the same, but those instance tiers don't necessarily have to be the same pricing tier as the production ones. What about considering the high availability? So we also need to consider uptime availability as well by scaling, replicating, and so forth. But that also requires additional cost. So within the reasonable budget constraint, how can we do this cost optimization? In other words, we should find out the balances between business goals and budget. Throughout these cost optimization processes, we can reduce unnecessary expenses and improve the operational efficiencies. So as a part of this cost optimization, there are a few factors to consider. So on the slide, I put 3 things. The first one is choose the correct resources. And second one is to optimize the workload depending on the development or production or testing whatsoever, so that we can aim for the scalable cost. And the third one is we should be able to dynamically allocate or deallocate resources. What that means is that we can easily remove or delete all the resources if we don't need. Of course, there are other factors as well, but let's stick onto these 3 factors because they are the most common scenarios we are facing to optimize the budget. So let's talk about the first one, the choosing the correct resources. So we have the business objective that we hit 99.98% of SLO. SLO stands for service level objective. In other words, that's our business goal, meaning our application, Relecloud application, needs to be up at all time with 99.98% throughout the year. But how do we calculate the number, which is 99.98%? Wow, there are so many nines, and I'm experiencing a tongue twister for now, but let's try this. So if we look at the table on the left-hand side, we will see that services, the Azure services that we are using for the Relecloud have SLAs in between. And these SLAs lays between the 99.90% and 99.99%. Also, you might have noticed that there are two app service instances. One is for front-end and the other one is for back-end. So within our calculation, let's not forget to bring these two instances together. So while these numbers, like 99.99% or something like that, sounds very impressive and sounds very awesome. Oh, so everything is uptime availability is 99.99% throughout the year. But we need to calculate what the total SLO look like by multiplying all the SLAs together from Azure Active Directory to the Azure SQL database. Then so if we multiply everything, then we will get 99.56% of SLO. It means that our Relecloud application might be unavailable around 38 hours throughout the year. But that doesn't meet our SLO that we are aiming for, which is 99.98%. As a result, our Relecloud will get the brand damaged because of the unacceptable the uptime availability. So in order to avoid these kind of situations, we need to add a secondary region and distribute the traffic into these two regions. So then SLO calculation is getting trickier, because we have to consider in two regions at parallel. So we should do the same math calculation here. I know that we didn't expect those kinds of math calculation in this session, but that's what it is. So let's add another the second region to our plans to use formula like this. So we have the formula of 1 minus n to the power of r. Then where the n means our SLO, which is 99.56%. And r means the number of regions, which is 2. So if we substitute these n and r with these numbers, which is 1 minus 0.9956 squared, it becomes 99.99%. So which is the higher than our SLO. But we haven't taken the traffic distribution yet into consideration yet. So we need to add another as a front door instance in front of them, which has the 99.99% of uptime availability. So if we multiply this as a front door SLA with the multi-region SLO that we have calculated before, then the final calculation will be 99.98%. Now, I know this calculation formula seems to be a bit overwhelming. Let's see the formula from a different angle. So I have confused at the very first time. So let me find another way to see to understand how this calculation is resulted in. So we have two regions. Primary regions, SLA have 99.56% from the composite calculation before. And we have also another secondary region, SLA of 99.56% as well. And which means we have 0.44 unavailability throughout the year. So there are chances that both regions go down at the same time. And its probability will be 0.0044 squared, which is 0.00001936. So as a result, either region is available at any time of the year is 99.99% of SLA. That's how we calculate it. Now, we need to distribute the traffic into two regions with as a front door. And as a front door, as I said, has the SLA of 99.99%. So we have composite SLO with 99.99% multiplied by as a front door SLA, which is 99.99%. So the final composite SLA is 99.98%. Therefore, the business goal of our SLO is 99.98%. That's how we conclude to calculating our the SLO. So we have covered how to choose correct the resources for our uptime availability. But by doing so, we added secondary region, which means we need to spend additional cost at the same time. So this time, let's take a look at the workload to optimize the cost associated with our Relecloud project. So I will move on to our GitHub repository to see our bisect files that provision the resources to as well. So let's take a look. So here we go. So this is our the GitHub repository, and this is all the bisect files we have already used to provision our Relecloud application. And first of all, the main bisect file is the main entry point we use to use an azd provision command. When we look at that, we have two flags. One is isprod and error set as false because we are going to deploy and provision on the non-production environment. But if you want to use this bisect file for the production workload, then this flag should be set as true. So once we use that, then it create another variable that is prod boolean, so which will be setting for the modules. And another interesting factor is that this one. So this variable as well. So it checks the secondary Azure location value parameter. So if it is empty, then we are assuming that this workload is not using the multi-region deployment. So that's that variable we'll be using that. So if we move on to the different one, then we have, hang on, let me check out. Where is it? Okay, so let me check out this the multi-region deployment. So when we use this the thing, then here we go. That's the conditional factor. So if multi-location deployment is true, then we are going to provision DevOps identity setup module as well. And also, if we use multi-region deployment, we are provisioning the same resources, same set of resources into the secondary region by using the same resources, the bisect file. So that's how we consider the workload. And then depending on the workload, we can decide which one. The second, we only use a single region, or we can use the multi-region as well. So let's get into here. So we use isprod boolean value for the to check whether it is the production workload or not. So let's go into this resources.bisect file. Then okay, so let's get into the first one and the second one. So let's check this out. If this is a production workload, then we have to prevent the key vault access from the public. So the public network access should be set as disabled if it is production environment. Or if it is non-production, then we can add, we can enable that key vault public access, something like this. And also, another one is that if this .NET application is production workload, then we use that ASP.NET Core environment as production. Otherwise, we use development. And also, we choose app service plan SKU value. If it is production, we use P1. If it is not, use B1, something like this. Also, it also determines that something like this. So this is some example, and go into the app service auto scale settings here. And if it is production workload, these auto scale settings is only provisioned if the production workload. So if it is non-production workload, we don't need to worry about auto scale settings or something like that. And this is a SQL database. This SQL database has also different flag. So this is all about the cost optimization stuff. So if it is production workload, we use premium tier. If it is non-production, we just use a standard tier or something like this. Or we can set up the geo-replication stuff. If it is production, we only use a local replications thing. And if it is a production, we need to consider geo-replication stuff as well. Also, there is another one. Another interesting factor is that on the Redis cache. So it has the same pricing tier like this. If it is a production environment, we use standard. If it is non-production environment, we use basic or something like that. Another interesting factor of that within the Redis cache, the module here is that. So we are going to use provision deployment script only if it is non-production environment. That's how we can use this isprod, the flag for each the module to provision individual resources, something like this. So this is how we can optimize our the workload, optimize the other resources based on the workload. So if it is a production, we need to use the higher tier. If it is not production, we can reduce the smaller tier, which is we can save the cost or something like this, right? So we have covered how we can provision resources depending on the workload, like dev, test, and production. How different we can differently we use the bicep workload. So every single Azure instance is provisioned by bicep and Azure Developer CLI, which is considered as infrastructure as code, as Aaron mentioned. And then it should be easy to destroy the resources if we don't need, right? So how can you achieve these kind of things? It's as simple as typing AZD down in the console application. By doing so, we can we don't have to hold the unnecessary Azure resources on the cloud. That means we can save the cost. So let's take a look. So we have the Azure bicep here, and then we have console here. Also, we can simply destroy all the resources by simply clicking and deleting the resource group in here. But it doesn't guarantee the some resources still on the cloud, like soft deleted the resources such as key vault or Azure configurations stuff. Those kind of things is not directly deleted right away. It is kept around 7 days or so until it is fully deleted. So if we want to delete everything at once, then I think I would recommend using the AZD command. So let's say AZD down. Then we have 3 different the parameters as well. Say the first one is false. False means it doesn't ask to confirm. Are you really sure? We don't. It doesn't ask me like that. So it just deleted. And the second one is purge. So purge means it delete straight away all the resources even if including the soft deleted ones like keyboard or API management or the app configuration stuff, something like this. Also, no prompt means if there is any other the prompt is popping up and it just ignore it. So once I type this, and it will delete everything down. And also the deleting takes time, around 10 minutes or so. So yeah, that's how it is. So we have covered the three stuff. One is choosing the right resources by considering like uptime availability or something like that. And second one is we can choose the pricing tiers based on the workload, right? And the third one is that we can easily delete all the resources if they are no longer necessary. So that's how we can consider as cost optimization. Right. So I'm going to hand over back to Aaron for to conclude our session.
Thanks, Justin, and thanks for giving us that good walkthrough on the way that we can do cost optimization. Obviously, that's a really important one when we're thinking about this cloud migration because, well, as you saw, we're doing a multi-region deployment, and you're not going to need that necessarily for a non-production workload. So be able to do things like have flags that you pass in that you can then do conditional checks with inside of your infrastructure files to make decisions on that. Like that's going to make it more intelligent in the way that you deploy, and also avoid having these resources that hang around forever, or resources that are oversized for non-production workloads. We saw how we can use the Azure Developer CLI to spin up and spin down the environments and things like that. But you can also use that because it's just a command line tool from within inside of like a automated deployment pipeline, so whether it's Azure Pipelines or GitHub Actions. You can call that same provision command. So stand up a brand new infrastructure set for like a branch that's being worked on. Have you got a long running branch that you're collaborating with your team on? You can use AZD to provision infrastructure for that. And then we can pull that down and move it across to destroy it when we merge that branch into production. And in the code that we've got in that sample repo, we have both GitHub Actions and Azure Pipeline workflow files for doing that using Azure Developer CLI. So you can go check out that and see how you can do that repeatable deployment there as well. But with that, that kind of brings us to the end of what we had to cover off today. So we're going to be covering off a few more pieces over the next couple of weeks. We've got about 5 weeks worth of 4 weeks worth of remaining content. Next week, Justin will be back to talk about reliability, and then Justin and I are going to be swapping in and out each week to cover off the remaining topics of security, operational excellence, and performance efficiencies to round us out in September. But thank you for joining us today. If you've got any questions, do feel free to drop them in the chat. But I hope this has been insightful. I hope you've got some ideas around how we can get started building reliable web applications and using the reliable web app pattern on Azure. So yes, let's have a look at the chat and see how we're going. I see a comment in there from anonymous NK asking whether or not the conditionals would be a good way to go, or should we have more flags that get passed in to the bicep file? Do you have any thoughts on that one, Justin?
Well, what's the question about? Rather than all conditions embedded in the code, wouldn't be better to externalize parameters? Yeah. So actually, that's totally up to you. So we can set the parameter. We can set the parameterize. We can parameterize all the flag outside the bicep file, or you can internally set the flag depending on the other parameters. And I think you can use them both ways.
Yeah, I quite like using a single flag to whether it's to represent a production versus non-production or whatever the case may be, because then internally you're able to apply that in multiple different ways. Like we saw that you can use it to adjust the skew of a like an app service or a SQL database or a Redis cache, you can then use it to enable or disable certain features, such as the app scaling or external access for Key Vault and Redis cache and things like that. Whereas to parameterize that, you end up with potentially quite a large parameter set that you need, to replicate all the different SKU variations that you want, and so on and so forth. Now, obviously, we've only done it with a single Boolean of like is prod versus like prod versus non-prod, but there's no reason why you couldn't have that as a string variable, and instead represent like a named environment is this development, UAT, pre-production, production, whatever the layers you might have, and then have, again, a more nuanced set of approaches that you've got with inside of that to scaling. So maybe your pre-production is almost a full mimic of the production, but like has some slightly different config options set on and off.
Yeah, I agree. Any other the questions on the chat? We can look at.
Looks like we've done a good job of sharing our knowledge, because it seems like we haven't left anyone with any more questions for today. Okay. So I think we could probably wrap it up there. Thanks everyone for joining us, and we'll see you again next week.
Yep, we'll see you next week. We're talking about the reliability.